Good morning, dear students. On behalf of SA Engineering College, I wholeheartedly welcome you all for the Tech Series 4.4 program on Understanding Embedded System from Bits to Brilliance, conducted by Triply Department. SA Engineering College has 26 years of excellence with well proficient mentors, extraordinary environments with good research facilities. We have 11 UG program and 6 UG programs. SA Engineering College is an autonomous institution affiliated by Anna University, aggregated by NAC and NBA. Triply department is one of the core department in engineering. Success is a sum of small efforts repeated day in and day out. Small cheer and great welcome make a feast. We are proud to welcome our alumni, Mr. R. Lakshmanan, is the guest speaker of this event. He has completed his bachelor degree in the year 2020. He is presently working in V-Titan Corporation Private Limited as embedded software engineer, Chennai. We welcome you, sir.
Yeah,
Online learning has opened up a world of possibilities for education, breaking down barriers of time, distance, and accessibility. So, why not take advantage of the power of online learning and embark on your personal growth and personal growth? The possibilities are limitless. I welcome all the delightful participants to gain the knowledge to be shared by our guest. Now, I hand over the section to Mr. Lakshmanan.
yeah. Hi, guys. Thanks, Ms. Sita. So, let me talk about me. First, by myself. So, basically, I completed my bachelor's in SA Engineering College, which makes me the student who learned from SAEC. Uh, Currently, I'm working as an embedded software engineer
Lakshmanan,
in VTET. Yes.
can you speak louder?
Okay. Is it fine?
Since audible is very low, that's why.
Okay. Now,
Yeah, you continue.
okay. Yes. So I'm working as an embedded software engineer in V-Titan Corporation Private Limited. So basically, I'm currently working with medical devices, and also I'm an electronic hobbyist who build things for automation and automating things using IoT and all those stuffs. Uh, why? I mean, like, how I came to embedded. So first, when I entered into the college, during first year, I came to know there was a thing called symposium. That's a new thing for me. So when I first went to symposium, I presented paper, and at that time, I just saw a project presentation where people started to develop things and presented projects with the electronics and all those stuffs. At that time it was a new thing for me, so I started to search how they did and how they started to learn about those stuff. So at that time I just came across a development board called Arduino. So Arduino is a starter kit. Using that we can do some simple applications like LED controlling things, motor controlling, and also you can do or develop robotics using that. It is a basic thing for starting in embedded. After that, when I moved to the third year, there are some advanced controllers there. So I came to know about that. So after that, I started to learn and I want to work with that controllers. So those controllers are nothing but AVR. Arduino is also kind of an AVR controller, but the thing is, in Arduino, there is one IDE called Arduino IDE. Using that, you can easily write with basic C code, which can be understood by students or whoever writing. But in ABA controller, there is one thing called bare metal coding. So
Lakshmanan,
with that, yes.
sorry for the interruption. Can you speak
Okay.
louder since we couldn't able to hear
Is it fine?
some better louder, please?
Okay. Is it right now fine?
Okay, you continue.
Okay. Yeah, I think there are some technical glitches. Okay. So yes, there is one. There is a type of coding called bare metal coding. So I started to learn that. So with AVR controllers, I first developed an project called Line Follower. There, there are some difference between Arduino coding and bare metal coding. So when I started to learn bare metal coding, I came across a thing called assembly language. So with that, you can directly speak to the controller. So that's the second thing I just learned. And there are some different types of controller beyond Arduino. So Arduino is just a basic thing. So beyond that, you have Raspberry Pi and Cypress board and Texas Instruments and XP controllers and all those stuffs are there. So after AVR, I came across with ARM controllers. So with ARM controllers, I just entered into one competition called ACCS competition, which is held in IITB, IIITB in Bangalore. So during college period, I got sponsorship from college, and I just entered there, and we started presenting our presentation. There at that time, ARM controller is kind of a new thing for me, which is way advanced than Arduino and AVR. And I started to learn with that ARM controllers. So basically, the difference is AVR is better for switching controllers. Like you can do some robotics applications and industrial applications and all those stuff. With ARM controller, you can actually build a mini computer or a kind of IoT system which runs on its own operating system like that. So these are the things I came across during my study period. And after completing my college, I got placed in a company called Robotics Learning Solution. So which is nothing but an product development company for education system. There I started to work with a device called Firo. So which basically nothing but a toy car which will be helpful for students to learn how programming is easy. So in that we just gave a card, and by swiping it, it will program the device and it will directly run. So I just worked on that product, and after that I just moved across to the medical device company, which is nothing but a Phoenix Medical Systems. There I learned how embedded systems can be precisely handled for helping patients or people. So in medical industry, I just learned like even a micro level change in the electronic system affects a major thing for the people. So there I just learned more things about medical devices like baby monitoring system and all those stuff. So after that I moved here for VTitan. So this is basically about me. Now let's come to embedded talk. So currently in this world, everything around us is basically an embedded system. If you just take a mobile phone, it is an embedded system which has a CPU in it, and you can easily access it. And if you take a charger, it is an embedded platform. So currently, our mobile phones comes with PD charging, which is nothing but power delivered charging. So it has a controller which controls the charging current for the mobile phone. So some mobile phone needs 50 watts, some mobile phone needs 20 watts. So that can be controlled inside the charger with embedded systems. So these are some basic applications and examples of embedded systems. And um, there is one more thing for embedded system. Like there are some numerous application. Even a mechanical engineer or an IT people can be get into the embedded system. So it is not actually a specific programming. Specific program for certain disciplines. So any people can learn embedded systems. That's my thing. Just I'm saying. Okay. Since embedded is incorporated with software and hardware. Software is one of the important thing for embedded and also hardware. So when you are entering into an embedded systems domain or stream, you just need to learn about more thing about hardware also. So whenever you got stuck with some issues on the hardware side, like if any capacitors burst out or is there is any EMF or EMI interference. So you just need to know what hardware you're using and how you can change it for the embedded system accordingly to work on your applications. So there are some equal benefits for software and hardware here. The next thing I want to talk about is software. So basically, embedded system is a thing you can directly talk with controller, or else you can say it as a CPU. So uh, machines, you can also say machines. We cannot directly give an instruction like hi, hello to the computer. So instead of that, we need to give some instructions. We can say it as an instructions, which is nothing but a line of codes. So the computer understands only 0 and 1. It's kind of switching thing which will help the controller to know more. To give this give that 0 and 1 instruction, you just need to give a program. That program is nothing but a C or C++ code. Since C and C++ executes faster and communicates easily with embedded system, we are sticking with C and C++. And there are some languages like Rust, even Python is there, but Pythons and all are uh, kind of taking longer processing time for compiling and all those stuff. We are sticking with C and C++, which can directly talk to the controllers. So, I mean, embedded C is different from actual C or C++. There are some difference, like in if you're writing any program in C or C++, we can actually write the logic whatever or however we need. But according to the embedded systems, we need to more precisely give uh, the code. Like we need to actually think of memory and storage constraints. Since embedded system it has some low memory, we need to think of writing it in a precise manner that can be able to accommodate with the memory. So so here we go with some bit manipulations or bit operations, which are nothing but and or like that. Even a simple functions can also be written in bit application. So when you are entering into an embedded system, you just need to learn about bits and bit manipulations. So these are the basic stuffs about embedded system. Okay. Uh, the next things are the application and how we are going to enter into an embedded systems. So when you're joining college, there are so many things. So instead of learning your syllabus and all, there are so many things that you can explore in college. So whenever there is a project presentation, please try to involve yourself in the project presentation, or any kind of event if your college is holding or something like that. So when you're going to involve in that type of things, so you will start to explore more things. Basically in project presentation, you will start with some basic projects which can be done with Arduino. So after that, you just learn how the application works with Arduino and what are the different possibilities you can do with Arduino. And there you will explore how embedded systems or microcontrollers can be used for our environment or the people's application. So after that, you start to explore all the components which can be involved in embedded systems. So with that different things, you can actually explore more stuff with the embedded. So this is my advice. So kindly take it. Now I'm just going to start my presentation. Okay. So it's just a simple thing about understanding embedded systems from bridge to brilliance. Okay. First, what is embedded system? So, as I said, it involves both hardware and software. So, it is nothing but a computer system which are designed to perform specific tasks with electrical systems or some kind of a larger mechanical system. Just think like it has a piston or some kind of motor attached to it. We need to move the piston. So with the help of motor and some electronic circuits, we can actually control the piston movements and the motor controls. That's how embedded system works. So basically the examples what I gave are here. So mobile phones, washing machines, and micro ovens, even digital cameras, even gaming consoles are under or developed with some embedded systems. Uh, even even our rocket or missiles which can be designed using embedded systems. So these are the examples and applications of embedded systems. Okay, embedded systems involve some components in it. Like human, it has a brain. Just compare ourselves with embedded system. So we have a brain, and think our eyes and mouth are input and output device. Our eyes an input device and output device is our mouth. So just think in that way. For the computer system or embedded system, the processor is the brain or the controller, and memory, which stores the data and instruction, and input and output device. Take our mouse as an input device for the computer, and the output device are nothing but the speakers and all. According to inputs, I mean, according to the embedded systems, inputs are nothing but the sensors what we are using just to detect some light or some sound or even gas. So these sensors are comes under input, and output devices are nothing but the displays, LCDs or OLED displays and all those stuffs. These are the components involved in the embedded systems. These are basics. Okay. Now, how embedded system works. So, if it has a brain, it needs some instruction to execute or to process. So, those instructions can be given by us in the form of coding. Those code can be stored in the memory. Like the memories are, I mean, like in the memory, the stored in the memory, and the process will be processed inside the processor, and after that it will execute the performs, I mean, task which can be performed by the processors. So basically first it will hold the memory with code, and after that it executes the perform, I mean, the task. After that, during the task, if it needs any input values or data, it will fetch from the sensor, or if you have anything inside a variable, it will take the value and it will doing the process. And after that, if you want to give some output, it will be transmitted to the output device and displays it. Sensors and actuators will interact with the environment. Environment. If, as I said, the sensors are the input things which will be interacted with the environment and getting all those data from the environment. Actuators are nothing but moving motors which are connected with the embedded system with electronic signals. So these are actuators which will be shown as an output. Say it is a motor. So sensing some light intensity, if you're adjusting the speed of the motor, then motors are nothing but the actuators and sensors are nothing but the LDR, communication protocol. So basically, uh, to say something or to give an instruction, say some, I need to assign a task to a student or to my colleague. I just need to communicate with them, right? So basically, I'll talk to them and I'll just exchange some information with them and I'll do the work. So like that, in embedded system, there are some communication protocols which can be used to transfer the data from one device to another device, or some or one from controller to the sensor, or to sensor to the controller. So these communication protocols are have different types, which we can say it as UART, SPI. UART are nothing but Universal Asynchronous Receiver and Transmission Protocol, and SPI, I2C, even our Ethernet and Bluetooth, all those stuffs are comes under communication protocols. So each protocols have its own advantages and disadvantages according to their applications. For short range distance, we can use SPI. We cannot use long range distance. And wireless and Bluetooth has its own applications like transferring data in a packet way. So like that. So communication protocols are nothing but a protocol which can be used to communicate between two devices. Okay. Types of embedded systems. So basically, I said like embedded system is all around us. Everything comes under embedded system. So what the device and what are all things we are using is it holds embedded systems and all. Okay. So under that, we have certain categories like types of embedded systems, which are nothing but general purpose controllers, microcontrollers, and ASICs, application specific integrated circuits, and FPGAs, field programmable gate arrays. Okay, let's talk about general purpose microcontrollers first, uh, which are nothing but AVR and ARM. So general purpose microcontrollers are nothing but which can be used for general applications and robotics and also in industries, which can mean this general purpose microcontroller can be used for various types of applications, and it can also be easily accommodated with that application. ASICs, application specific integrated circuit. Let's say we have a phone which need to be tweaked for performance. So at that time, this ASICs comes in. That particular controller or a processor can be modified for that particular applications. So that is ASIC. Next thing is FPGAs. So FPGAs are field programmable gate arrays. This controller, after the manufacturing, we can easily change whatever the customization we need to do on the controllers. Say if you want additional input or output pins, we can also do that using FPGAs. So these are the different types of embedded systems which are currently present. Importance of embedded systems. So as I said, they make our day uh, easy and more efficient for us, and the devices are getting more smarter every day. Say Alexa, it is a device which can be controlled, which is a device used for controlling applications of our household. Say using Alexa, we can also control AC, fan, TV, or whatever the thing by saying our voice. And with embedded systems, we can automate process. Say there is this say this application like if the daylight arrives, just turn off the light which is on the outside our house, and after the thing is like when it comes to evening, it I mean automatically turn on the light. So this is a basic application and how we automate the process, and it enables us to communicate between devices, say IoT, as I said in Alexa, so which will be connected with internet. So we can able to control Alexa from our mobile phone using our Wi-Fi or internet. If we are outside, we can able to connect it with the internet, which is inside present inside our home, and we can control the application. I mean appliances. So these are the important things of embedded systems. Also, currently for AI, we need some powerful performance or hardware devices. Even AI is also dependent of embedded systems. If embedded system is not there, AI is kind of a bit smaller thing. Some examples, as I said, smartphone, ATM, and traffic light controllers. So these are the examples of embedded systems. Okay, future trends in embedded systems. As I said, Internet of Things will come under embedded systems, artificial intelligence, and wearable technologies. So, when I started to work in medical devices, I basically started to explore about wearable technologies. There is one company called Massimo. I started to work with their devices. They basically have their idea like making a device smaller, which can be used for sensing heart rate, blood oxygen level, and all those stuff. The device will be of basically a coin size, which holds a battery in it and also an Bluetooth in it. So that's how embedded system can be. We can able to make a thing smaller, which will be more powerful for identification of different things. So that will be happen in wearable technologies and artificial intelligence, making our systems more intelligent and autonomous. As we said, ChatGPT is a thing where right now which gives an information about uh, what we are asking, And also for using ChatGPT, we can able to build a robot which will be controlled. So right now, ChatGPT is nothing but an LLM, large language model, which will be only useful for giving informations. But also we can incorporate with embedded system after some device inputs. We can able to create a robot which can be which can have their own intelligence. Next one is Internet of Things, IoT. So IoT is nothing but as I said, so um, which with internet we can access different devices and we can able to communicate with different devices, which is nothing but IoT. Say from my phone we can able to easily control light and all those stuff, even if we are not in home. So that is IoT application. So the conclusion, uh, as I said, as I'm saying, embedded systems are all around us and making our life easier and more efficient. Understanding that embedded system is kind of a bit difficult thing, but since we are using it in our day life, it will be easily accessible for us. So this is my presentation conclusion. And the next thing, okay. So uh, uh, right now I just said some basic things about embedded systems. There are so many things involved in embedded systems. As I said, memory. So the memory has some different types like ROM and RAM. So when it comes to embedded systems, we need to know more about all those components and how we are using it. Okay. Um, Let me show you some controllers which I have and I have used, and let me say how I used it in my applications and all. So I'm just starting my camera. Okay. So while starting, I just use this board, which is nothing but a nano. This is also an Arduino, and this is also an Arduino. This is Uno, and this is Nano. The difference between is it has some input pins, but it doesn't have some inputs, and these are the major difference. But both does the same thing. You can usually, I mean, actually get it for a best price for 300 when you go to the rich street or somewhere. If you are ordering it in online, you can get it for more than 500 something. So these are the basic thing if you want to learn in learn embedded systems. And after that you have, I used to work with mega boards. So this board, why I chose is like I need some more micro, I mean servo motors to control for an application. So I use this is also same as an Arduino Uno. Basically you can start with these three if you're new to embedded systems. And after that I just moved to ARM controllers. There is in between gap. I said I used to work with AVR. Since this Arduino has an AVR chip, instead of using Arduino IDE, you can directly use Microchip's own IDE, and you can start to develop with some bare metal codes. So for that purpose also I use these boards. And after that I just went to a big microcontroller. I just actually don't have it, which will be used with programming in Microchip IDE. So that I used in my industry, like in my company when I worked. So after that, in my college days, I came across some ARM controllers. So basically, I had a Cypress board. So this actually can emulate a game. So in this, we can install an OS, and we can create some ritual or emulation uh, thing. Like we can actually exactly replicate the game which we played in our childhood. So for that thing, I use this Cypress board, and this is a very powerful chip, uh, which is equivalent to our mobile processors, we can say. And the next thing is this MKR 1000. So this is also an Arduino based board, but it has an ARM processor instead of AVR. So it has Wi-Fi and Bluetooth inbuilt with it. So this can be used for applications like IoT and data transfer, and even you can also use this thing for hosting your web applications. Like you can host your own page, and from there you can control your connected devices. You can get sensor data, and you can show it on the web page. So these things I've used, and the next thing is like Raspberry Pi. I mean, like currently this is also an basic thing. If you are coming into an embedded system and started to work with Linux kernels and RTOS, so this device is nothing but a credit card size computer. You can run your own OS using memory card. So you just need to install a memory card, and you need to build OS for it, and you just need to insert it here. That's it. While you boot, you can connect monitor in HDMI and input out, I mean, like my mouse and keyboard here. So basically this works as a computer, but it has certain limitations. Like with general computers, this processing thing can be slow, and these are for basically am used for doing some industrial standard applications with these things. Say if you are just building a robotic arm, you need to control their access with some application in it that should be incorporated in a computer. So we cannot directly connect those motor with our conventional computers. So we are just going to it, and inside it you can just build your own application, and you can run it, and you can use monitor to connect it and see. With those type of things, it is a powerful credit card size computer, or we can say it as a minimum size computer. And after this, there are certain controllers which can be used with RTOS. So as I said, this is a powerful chip. So this also involves RTOS, which is nothing but a real-time operating system. So basically, with RTOS, you can build your version of OS which will be specified for a certain task or a particular task that can be done with RTOS. You can do multiple threading instead of line by line execution with RTOS and all those stuff. And the next thing I want to say is yes, as I said earlier, microcontrollers and processors currently what we are using can be emulate some games like which we played in our childhood. So I'll show you one thing. I just bought a console which is R35S. So this is a gaming console which have rock chip uh, controller in it. That is nothing but a similar controller which is equivalent to this Raspberry Pi. Currently, I'm holding Raspberry Pi 3, but right now they are starting to roll out Raspberry Pi 5, I think so. And those things are powerful, and Raspberry Pi 4 is more powerful than these things. So here, this rock chip controller, what it does is like this is also basically an embedded system. So like in Raspberry Pi, we can create an OS and we can install it using this memory card. So right now I'm using Arc OS for building my emulation system. After that, I'll install this OS here. For the game thing, I have another slot for games and all those stuff. So here I'm using another card, 128 GB. So it holds more than 17,000 games in it. So this is another application as an hobbyist I'm doing. So instead of Arc OS, you can do some emulation stations OS and all. So using this, you can do. So these are some basic simple applications what I do in my day-to-day life. And yes, so these are the things I just want to talk and I just want to say about embedded systems and how easily you can come in. One more thing, when you are stepping into an embedded system or an embedded discipline, starting you will be just struggle how to learn and how will be. There are some vast content in YouTube which will taught you how to start embedded system from basic and all. Even I had an opportunity in my college. I just started learning this embedded system with my seniors guidance, and also there was an automation center there. With that we started to learn embedded systems over there, and after that I got some support from my college professors and staffs. They helped me a lot for entering into and competitions and all. So we also had some sponsorship from college for involving these type of stuff, and also we go to competitions and we win stuff using our projects and all. So this is one way of learning. The next way is like you can involve yourself in with internet. So in internet there are some vast content in YouTube, and also there are some forums, and you can also use Reddit to learn. So with those things you can actually learn from basic, and in forums and all, if you are having any simple doubts, if you post it, there are some 100 people or more than 1,000 people which they'll start to comment your post, and they'll start to explain you what you're doing, and what you're doing is right or wrong, and they'll suggest some idea to do it. So you can use those forum for your learning curve and all those stuff. Even though if you're learning after that, if you're doing some simple applications, and if you're working with some simple applications, then only you can understand how embedded systems works. And most probably beginners will be afraid of starting to learn C or C++. But as far as I right now, I've just learned JavaScript, Java, and all those stuff. But still, C and C++ are the simplest programming language as far as me. And yeah, you can also use Python. As I said, in Raspberry Pi, you can use Python OS. I mean, sorry, Python program for running your applications, but the execution time will be more. Even though Python, if you are using Python, at the background there is a package called Python which will be written in C program. Anyway, the Python programming is converted to C, and then only it will be communicated to the controller. So learning C and C++ is one of the best thing. And after that, if you got a good hand on C and C++, you will have some basic knowledge how programming works, and you can start to learn more different languages. So only the thing in programming is there will be change in the syntaxes only, not in the logics. So if you are familiar with programmings and logics, you can able to adapt to any other languages or any other programming languages like Rust and all. Currently, industries are adapting to Rust after C. Still, industry uses C. We are also trying to move to Rust since it has some advantages on the embedded side. So that's the next thing about programming. After that, one more thing I just want to say. Okay. So yeah, this is about programming part, and the next part is about hardware. As I said earlier, you will be incorporating. I mean, like you will be started to work with hardware and software with both together. See, I had a board, and when I started to work, I just burst one capacitor in it. I think it will be shown here. I don't know whether it is visible in camera or not. Okay, so to identify that, I mean, I thought like this board itself is burnt, so I can't use it. After starting and working with embedded systems, I just started to explore about, started to explore hardwares, and I started to learning schematics. Schematics are nothing but a diagram which shows how the controllers and how the other components are connected with the controllers, a kind of diagram which shows the connections between them. So with that I can able to debug those capacitors, and I changed it. It just, I mean, the capacitor costed around me of 10 rupees only. After changing that, it started to work as normal. So if I don't know about hardware as an embedded system, as an embedded engineer, um, I think is like you will be spending more money with that. And also, understanding this hardware working is also an important thing. So, as I said, EMF and EMI are a certain things which will be do annoying things with your applications. So once I just started to control a motor, there some EMF and EMI induced in the board, and when I started to started to run the motor, it stopped suddenly, so I couldn't able to find it. So so if you know hardware thing, you can able to identify what is the issue in the board directly instead of your program. Sometimes your program can do some nasty stuff, and also sometimes your hardware thing will do some nasty stuff. So to understand those things, you just need to know and how embedded system works with hardware. So this is the basic thing I just want to give as an input. So thank you. Hello. Hello. Deepta, are you there? Okay. If you have any doubts, just post it in the comment section. I'll try to answer those questions if possible.
Lakshman, can you hear
Since
us?
I couldn't see any questions, I think we can wind up the session.
Mr. Lakshmanan, could you hear us?
Yes, yes.
Lakshmanan,
Yes, sir.
can you hear us?
Yeah, yeah.
Thank you for a very nice session. I have one question.
Thank you. Yes, sir.
How can a school student start with embedded system? You told YouTube's.
Yes, sir.
Uh, can you enlighten on it?
Yes. Uh, uh, just a thing. There is one blog post called Steppy Channel, which has an YouTube. So there you can start from basic. Basically, what they do is like they'll start to teach you how you can control LED first with basic Arduino IDE program and also with some bare metal codes. After that, they'll start to teach you about PWMs. So PWMs are nothing but controlling LED with some digital electrical signals. So there you can adjust the intensity of LED. Say currently in our homes we can able to control the LED brightness for lighting the home. So those applications can be done with PWM signals. So they'll teach you how PWM signal works. And after that, you can also use analog signals to control the LED brightness. So what are the difference between digital and those analog signals? So that can be taught. And with some basic things, you can follow that step A school channel.
Thank you, Lakshmanan. Thank you.
Yeah, sure, sir.
Any more questions? Participants? If any queries, you can post it on chat. Yeah. On behalf of Tech Series 4.4 at SA Engineering College, I extend my heartfelt gratitude to all the attendees, speaker, and organization and volunteers who make this event a resounding success. We are truly grateful for your presence, support, and contributions. We have made a which have made a significant difference in making this event memorable. A special thanks to SAEC Media for their exceptional dedication and hard work in organizing and executing every aspect of the event. Thank you to our esteemed speaker, Mr. R. Lakshmanan, for sharing his expertise and insights with us today. Your knowledge has enlightened and inspired us all. We are truly grateful for your time and commitment. Last but not least, gratitude is not only the greatest of wishes, but the parent of all the others. I thank once again and have a cherished future.
Yes,
Thank you.
thanks, Deepta, and thanks for giving me this opportunity to speak in this platform. Thank you, Kamalakanan sir, who just approached me and said about this thing. And yeah, thank you. Thanks for the management also.
Participants kindly post your feedback, which I have posted in comment section. Thank you. Thank you, Lakshmanan.
Thank you.